Welcome back, trio. Today we're going to go over another video. This time we're going over right triangles. Given this right triangle, find the length of this side, CB. So the first thing we need to do is recognize this as being a special triangle. If I have 90 degrees here and 30 degrees here, that means this angle here is 60 degrees. So we can put 60 degrees right here. Not too much calculations, it's just all the angles is 90. If I got 90 here, that means these two angles in a right triangle have to add up to 90. 90 minus 30 is 60. Now we can see this is a special right triangle. It's called the 30, 60, 90 degree triangle. In this triangle, the sides have a special relationship in ratio to each other. If this is x, then this is x times the square root of 3, and this is 2x. Now sometimes it's hard to remember which one's 2x, which one is root 3. Well, the easy way to remember that, root 4 equals 2. So this one is bigger than root 3. So this is the middle one, x root 3. Because if I took the square root of 4, that would give me 2. Square root of 3, therefore, must be smaller than 2. So it's 1 point something. Now that we know our relationship and our ratios, we can identify the 90 degree with this side is 10. That means the 30 degree has to be half of 10, which is 5. And this one has to be a little bit bigger than that, which is 5 root 3. And we're done. CB equals 5 root 3. And if it's feet, then we keep it as feet. Always make sure you have your units, and I'll be back with another example. Welcome back, trio. Here we are with another example. So I'm taking that first concept to a whole new level with trig, but we're still going to use right triangles. Here it says solve sine x equals 1/2 for x being between 0 and 360 degrees. So we can first think about the unit circle and draw the xy axis with an invisible unit circle. And if I do that, I have this, and we can have a triangle here, because we're talking about sine of x equals 1/2. This is x. Let me make this a little bigger. We have sine equals 1/2. If we know the idea that all students take calculus, that means sine is positive in the first quadrant and sine is positive in the second quadrant. We have this sine equaling a positive 1/2, therefore we are either in here or here. Now, we can also use the idea of SOHCAHTOA, saying that sine equals opposite over hypotenuse. So that means we have opposite over hypotenuse. And I see we have, you hear? Hi. We have 1 and 2. That means from the previous example, we have that 30, 60, 90 degree angle, 30 degrees, 60 degrees, 90 degrees, where this is x, x square root 3, and 2x. So we have that ratio. We have 1 and 2, 1 and 2, that means this side must be the same as root 3 times 1, or just root 3. Okay, so looking at this, we can also see that we have it on this side, where we have opposite over adjacent. So this is one opposite over hypotenuse. And that means this must be root 3. But because we're going this way, this root 3 is negative. Now, we just have to worry about our angles. Well, we know it's 30, 60, 90, and this x is going to the 1, which is my invisible 1 here. So, this means x has to equal 30 degrees. Or, x equals, coming over here, this would be 180 degrees. So we're coming up 30 before 180. So 30 less than 180 is 150. X equals 180 minus 30, x equals 150. Or, as we said earlier, x equals 30 degrees. This is done. We can't have it down here because we have a positive sign. Down here sign is negative, down here sign is negative. So these are only possibilities between 0 and 360. I'll be back with another example. Welcome back, trio. Here we go with one more example with right triangles. Again, this time we're using it as application for trigonometry. We have solve cosine x equals -1 over root 2 for x being between 0 and 360 degrees. Well, from knowing our trig, cosine is negative. If we remember, all students take calculus, tells us cosine is positive in the 4th quadrant and in the 1st quadrant. All the trig functions are positive in the 1st quadrant. So if we get a negative answer, that means we're either in quadrant 2 or quadrant 3. And cosine is adjacent over hypotenuse. So we can write this as square root of 2 and -1. And square root 2. Remember, whenever you have a negative, the negative never goes with the hypotenuse. In the right triangle, the hypotenuse is positive. So now, this one, we can see it's a little bit different. The other one was 1 and 2. This is root 2, or the square root of 2. And we have a special relationship with that. So let's go over that one. That one is 45, 45, 90. So this is x, x, and x times square root of 2. So now, whenever I see that square root of 2 inside the problem, I can recognize it as this. 90 is here, square root of 2 is here, so that makes sense. This is a right angle here. Okay, so we have a right angle. That means we just have to solve for this side. And if we have square root of 2, square root of 2 is the same as 1 times square root of 2. So that means my x is 1. Here, this side would be 1, so that means this side was 1, and this is -1. So this is 1, this is 1, and x, the angle, has to be 45 degrees, but we're over here, so we're actually saying 180 plus 45 for this one, or x equals 180 minus 45. So x equals 180 minus 45, well, that would be like 140 minus 5, so 135. And 180 plus 45, that's like 200 plus 25, so 225. So solving this one, we have to solve for x. X equals 135 degrees here and 225 degrees here. And we are done.